Hi everyone. In today's lesson, we're going to talk about geometric sequences. First, what is a geometric sequence? It's a sequence that uses multiplication to get from one term to the next. So the number that we multiply to each term is called the common ratio, denoted by the letter R. So geometric sequences use multiplication, and the thing we're multiplying is called common ratio, denoted by the letter R. So in each of these examples, I want you to find the common ratio and then determine the value of the 10th term. So 10 seems a little high, so let's make it the 6th term. So we went from 2 to 4 to 8 to 16. So we know that there's a geometric sequence. We are going to see what we're multiplying by. So 2 times 2 must give me 4. 4 times 2 must give me 8. And 8 times 2 gives me 16. So my common ratio is 2. My a sub 6, that's how we write the 6th term. Well, if these are my first 4, this is my 5th term, and this is my 6th term. So 16 times 2 is 32. 32 times 2 is 64. So 64 is my 6th term. Okay, how about here? 40, negative 20, 10, negative 5. So the numbers are getting smaller. So some of you must be thinking division, and you're absolutely right. We know that 40 divided by 2, or negative 2, gives me negative 20. We know negative 20 divided by negative 2, negative divided by negative gives me a positive. So 10 divided by negative 2 gives me negative 5. So this works as well. So my common ratio, we can't say divided by, so we have to use multiply. So we're going to say we're multiplying by negative 1/2. So dividing by negative 2 is the same thing as multiplying by negative 1/2. Okay, and then the last thing is finding the 6th term. So here's 1, 2, 3, 4, and then our 5th term, and then our 6th term. So negative 5 divided by negative 2 would give me negative 2.5, positive 2.5. And then 2.5 divided by 2 will give me negative 1.25, right? We should be dividing by a negative. So a sub 6 is equal to negative 1.25. And all you can do is use the calculator. I just did this in my head. I divided them each by negative 2. Okay, so there's a formula that will allow us to find any term of a geometric sequence, similarly like we did with an arithmetic sequence. So we have a sub n equals a sub 1 times r to the n minus 1. A sub n is any term. A sub 1 we know is my first term. R is my common ratio. And n is the term number, or number of terms. All right, so let's take a look at an example. So it says, find the 7th term of this sequence, 2, 6, 18, 54. So how am I getting from one term to the next? Well, it looks like I'm multiplying by 3. So my common ratio, R, is 3. The easy way that you can find the common ratio is just dividing any two numbers. So they have to be consecutive. So we have to do 6 by 2, 18 by 3. So if we're multiplying going forward, we have to divide going back. So you can take any two numbers. So like 18 and 6, they have to be next to each other though, and that would give me 3. Or I could take 54 divided by 18, that gives me 3. Or I could take 6 divided by 2, and then that gives me 3. So any two going backwards will give us our common ratio. So to find the 7th term, let's first write the formula one more time. A sub 7 is how we write the 7th term. So since I let n equal 7 here, I have to let n equal 7 there. So a sub 1 is 2. My common ratio we found is 3. And then my n minus 1, since n was 7, I have to be n is 7 here. So 7 minus 1 is 6. So a sub 7 equals 2 times 3 to the 6th power. So go ahead, type that into the calculator, and then hit resume when you're ready for the answer. All right, so I got 1,458. That would be the value of the 7th term. Okay. Next, find the number of terms in the sequence. And remember, the number of terms is the n value. So we're asking to find n. So let's start with the formula again. A sub n equals a sub 1 times r to the n minus 1. So we want to find n. A sub 1 is given to us as my first term, which is 3. R is the common ratio. So how am I getting from 3 to 9 to 27? Again, same example as before, looks like I'm multiplying by 3. So my common ratio, R, is 3. And we want to find n, so we're going to leave the n minus 1 alone. But a sub n is any term of the sequence. And if we don't know the number of terms, it will be the last term. So this is my nth term, which is a sub n. So we can put the 729 here. So the way you want to solve this is by isolating the base. So we need to divide the 3 out on both sides. And if you do 729 divided by 3, you'll get 243. And that equals 3 to the n minus 1. And now you can solve for the exponent by using logs or common bases. And it's helpful if you know a little bit about common bases. I can rewrite 243 as 3 to the 5th power, and this right side stays as 3 to the n minus 1. So since the bases are now the same, you can cross the bases off and set the exponents equal to each other. So we have 5 equals n minus 1. Add 1 to both sides, and we get that 6 is equal to n. Now, you could have used logs if you didn't want to find a common base, but I think if you can find a common base, it's a little bit easier. Okay, so again, similarly as we did yesterday, some questions will ask you to find the formula that you can use to find any term of a sequence. The following are all equivalent ways that we could ask this. Find the formula for the nth term, find the nth term, find the explicit formula. So here they want us to find the explicit formula or the formula for the nth term. So I'm going to do example 1 with you. So how am I going to go from 54 to 18 to 6? Looks like the number is getting smaller. So what we could do to find the common ratio is just divide. So we're going to divide maybe 6 by 18, start at the end, or you can divide 18 by 54. So go ahead, type those into the calculator, and then hit resume when you're ready. All right, so you should have gotten 1/3 for both. So what that means is that's my common ratio. So the explicit formula, I'm going to write it up here, a sub n equals a sub 1 times r to the n minus 1. So with the explicit formula, you leave the n alone and then you plug in everything else, just like we did yesterday. So a sub 1 is my first term. So here is my first term. In the sequence, my first term is 54. So 54 times. Next comes r, my common ratio. Here my common ratio is 1/3. And again, my exponent, we leave n alone, so n minus 1. Now, an explicit formula for geometric is super easy. We're done. We leave it just like this. We are not allowed to multiply these two things together because PEMDAS, or order of operations, would say that this has to go first. Then you multiply. Just for purposes of time, I'm going to skip number 2. Feel free to do this one for homework, and I can check it tomorrow in class. Okay, last but not least is in a geometric sequence, they may give you an 8th term, a 3rd term, and then they'll ask you to find some things like what's the common ratio, what's the first term, and what's the 15th term. So the best way to do this is to map it out. So we've got a sub 3 is my 3rd term, but we need to find the first. So I'm going to start with 1. So I'm going to start with a sub 1, a sub 2, a sub 3, 4, 5, 6, 7, and 8. We'll call this a sub 8. So I'm going to label 4374 is my a sub 8, and my a sub 3 is 18. So we want to find the common ratio. Well, the first thing we need to do is figure out how many times we need to multiply the common ratio from 18 to get to the 4374. So let's map it out. 18 times some common ratio will get us there, times some common ratio will get us there, there, and one last time will get us there. So technically here, I have 1, 2, 3, 4, 5 r's, which is the same thing as saying r to the fifth. So just like we did yesterday, we can just write it out. So 18 times the r to the fifth must equal the 4374. So all we have to do is divide both sides by 18. And we have r to the fifth equals, I'm just doing 4374 now, divided by 18. That gives me 243. So in order to get r by itself, we have to take the fifth root. It's the opposite of raising to the fifth power. So the fifth and the fifth root cancel each other out. Now, if you're looking for the fifth root button on the calculator, you're going to hit Math, and then you're going to hit option 5, where you'll see an X root. You're going to have to go in there and put a fifth root. So if you go ahead and type that into the calculator, you should get 3. Take a minute, pause the video, make sure you can do it. And we're going to use this information now to answer the question. So find the common ratio, part A. Looks like we already found it. R is 3. Then it says part B, find the first term, A sub 1. So if this is my third term and I'm multiplying by 3 each time, to go backwards, I'm just going to divide by 3. So 18 divided by 3 is going to give me 6, and 6 divided by 3 is going to give me 2. So A sub 1, my first term, is 2. And then last but not least, part C, find the 15th term of the sequence. So we need our explicit formula. And we know A sub 15 is represented as A sub 15. A sub 1 is my first term, which we just found is 2. R is my common ratio, which we found to be 3. Common ratio here. And the n minus 1. If n is 15 here, n has to be 15 here. So 15 minus 1. So take a minute, pause the video, and type this in just the way you see it, and hit resume when you're ready for the answer. All right, I got a very large number. I got 9,565,938. So if we go backwards, 9,565,938 would be the value of the 15th term. All right, guys, that's it for today. If you have any questions, now's a good time to jot them down, and I'll see you in class tomorrow. Have a good night.